Dear students, we are now in the second part, the final part of the robotics in physiotherapy. So we'll go through some of the robots. Main automated electromechanical gate machines. These are actually exoskeletons, robotic driven exoskeletons. You can see this is a product by Hokoma. So here the robotic gait orthotic combined with a harness supported body weight system used in combination with a treadmill. So here you can see the structures. The harness is the body is suspended upward like this. The weight has been half of the weight will be taken by the harness suspension, and then here there is a if the person is a paraplegic, then he can use his upper limb to hold the upper limb. There is a lever for that, and this on the both sides there will be the robotic systems which will go and fix with the hip joint, and then laterally the lower limbs are connected to each segments, and this segment will actually mimic the same kind of joint movements like in knee joint, how knee joint movements are there, hip flexion, knee flexion, all those will be controlled here through this system. It's a very efficient system, very costly also. So here this can be also used for quadriplegic patients also. So there again the upper limb support also will be there, and both for adult and pediatric patients also it is available. A robotic gait orthotic combined with a harness supported body weight system used in combination with a treadmill. So the giving treadmill is no need to ask the patient to move from one place to another. So here gait training can be given, and resistance and EMG feedback, or it can be here the therapist can sit and monitor on the in the screen. The robotic device, according to a pre-programmed gait pattern, guides patient's leg. The process of gait training is totally automated. Here, this is orthotic. This is a lower extremity powered exoskeleton, combination of a freely translatable and two-directional, that is two-dimensional actuated pelvis segment with a leg exoskeleton containing three actuated rotational joints, two at the hip and one at the knee. So this is you can see with very complex machines, lot of actuators, springs, spring loaded equipments, and you can see how complicated and difficult it is. So the whole this is in the lopus, they call it as lopus. It's a whole structure. It comes inside a whole big structurally built area inside which the robot is present. Here, this is another similar to the Hokoma's gate treadmill. End effectors, electromechanical solution with two driven foot plates stimulating the phases of gait. Here, mostly what you've seen all is used for gait training basically to improve gait. Two foot plates symmetrically simulating the stance and the swing phases of walk while the patient is on the device. So simulation of gait happens here. So it's a the brain will have a good experience of learning experience of gait pattern, as well as the sensory feedback from all the joint proprioceptive sense loading in the lower limbs. It's all very beneficial, therapeutically highly beneficial. This is the haptic system. Earlier we have talked about the haptic interfaces. See, the whole frame structure is there, and then here the patient is standing, and with all the suspension harnesses totally fixed. Upper limb, if you is able, you can fix. There is handles for holding that. So here this system, the whole system will move, and here we can see that it's called as a gate trainer GT1. It allows the evolution of the gate trainer GT1. It allows simulation of walking up or downstairs. The patient will feel like he is walking up and downstairs. The walking speeds can be fully adjusted to individual patient's needs. It has this 6 degrees of DOFs are degrees of freedom, 6 degrees of freedoms of force bar torque sensor located under each foot plate. Each foot plate torque sensor is there. So how much torque is being enforced will be, measure will be expressed, can be shown in graphically. It can be integrated into virtual GT environments. So here this movement can be integrated with a virtual environment, like walking in a park, or in the front we can put a large TV screen, color screen, and you can the patient can see the environment in which, and he will feel that he is walking through that environment, because the screen and the haptic walker will be integrated. Initial additional robotic training, first stage, followed by substitution of part of the conventional therapy with the robotic exercise, is a second stage. So initially just a substitution of the conventional therapy, such as passive movement, active assisted, those things can be done, and later on we will use the robotic as part of the exercise, that is second stage. So initial robotic training, first is to familiarize the patient with the robotic training. Second, it will be a part of the conventional therapy. Organizational point of view, the equivalence of robotic and physical therapy may be considered as a positive result. Now we'll see what are the benefits of using robotic. The introduction of robotic system into clinical practice is useful, at least in promoting a cost-effective use of human resources and the standardization of rehabilitation treatments. So cost effectiveness and use of human resources. So usually if you have a very severely paralyzed patient, you will require more, physiotherapist and aid assistant will be required to, do what a robot can do, like simulated gait, training programs. So this is the human resources needed will be reduced, and the effort and the work done by the what you call manual labor, basically done by the physiotherapist, will be reducing. And we can standardization, it also helps in the standardization of rehabilitation treatments. In fact, the workload of the physiotherapist can be alleviated, allowing him to focus on the target of functional rehabilitation. That is, the therapist can reduce his workload, and he can focus more on correcting and functional rehabilitation during individual training, and to supervise several patients at the same time during robot assisted therapy sessions. So more patients can be get care from a single therapist. So existing robots have the critical issues of capability of personalization and high price and performance. Now these part is the disadvantages what we are facing is, robots are very highly priced because of the technology, which is highly costly, and it is not affordable in India. So performance ratio, even though this is part of your syllabus, now only I think we have this in, Apollo Hospital in Chennai. We have a Okoma gate, gate assisted robot, which is exoskeletal robot gate trainer. So it's very costly one. So critical issues of capability of personalizing a particular patient is also there. So these problems are the disadvantages. Thank you, students. So with this, we come to the end of robotics. It's a very simple topic. Visually, you can expect only a short note from for your exams. Prepare well. Thank you.